Okay, today's lecture is important because we're actually going to talk about the function. Earlier was the notation of the function, notation we use in the function represent the domain and the range. You're going to see those in the future, all right? So, on page 6, example number 3. Determine whether each relation represents y as a function of x. Okay. I want you to spend a minute to read it, and then we're going to talk about it. All right. So, we are going to determine what is a function with 4 different ways. One verbally, one numerically, and graphically, and algebraically. So, what is a function? A function is a special relationship between x and y. Okay? So, basically, function means each x can only relate to one y. Each x can only relate to one y. All right, by knowing that, let's take a look at example number 3. Example number 3a, it says the input value x is a student's ID number, and the output value y is the student's score on the physics exam. Let me ask you, each ID, which is x, can have only one y or several y in this particular question. Each student, which is the x, so x is the student ID, and then the y is the score. Okay? So each ID can have only one score or several scores. One score. So each x can only relate to one y. So is this a function or not a function?
It is a function.
It is a function. So when you have the x only assigned to one y, it's a function. Okay? Make sense?
Yeah.
All right, part B. So the relation of a function is one x can only assign to one y. So if the x can only go to one y, it's a function. But if x go to two y's, it's not a function.
But if y goes to x,
that's fine. You know why? Because look at TV.
So y can go to 2x, but x can go to 2y?
So look at TV here. So this is x, this is y, right? So we have 1, 2, 3. So we have 2, 4. So if 1 goes to 2, 2 goes to 2, and 3 goes to 4. All right? I'm just use that example. So every single x is only going to one y, right? So 1 goes to 2, 2 going to 2, and 3 going to 4. So it is still a function.
yes.
However, if you have something like this, x and y, you have 1, 2, 1, 2, 3, right? 2 and 4. If you got 1 to 2, okay, 1 to 4. So if you have something like this, that is not a function because 1x is actually going to how many y's? 2. So this is not a function.
Come on. Okay. What? That's a okay.
Why are you shaking your hand? Don't erase that.
Okay.
Oh my lord.
I have it back.
So B. So B, look at the table. The table X, we have negative A, negative 5, 0, 3, 6. So for the people who don't have a book right now, we have X and Y right now. Okay? X is negative A, negative 5, 0, 3, 6. And then we have y, -5, -4, -3, -2, and -3. So, question. Are we using the x twice in this table?
No.
Very good. We're not using the x twice. What does that mean? Is this so the table represents y as a function or not?
Yeah.
It is a function.
Very good. It is a function. However, let's look at C. C, I'm just going to draw a rough table, okay?
Alright.
So we have this. It's a sideways quadratic function. And then we have this line. So let me ask you. The vertical line, x equals 4. So this is called a line test, okay? Vertical line test. So basically, what I'm asking you, okay? What I'm asking you is the quadratic here is a function or not?
It's a function.
But if it was faced up, right?
Let me not do this.
Oh, what is that? You know what? I just turned around, looked up. See,
Okay.
the graph.
So let me ask you this function, okay? The one in pink. The one in pink. Is this sideways U a function or not?
Yes.
Let's draw a vertical line. We call this a vertical line test. If you draw a vertical line in blue, okay? So if I draw this line. So this is x equals 4. But how many y this x equals 4 has?
2.
2. I'm going to use the green one. So this is the y, right? Let's say y equals 6. And this is also y. Let's say y equals -6. So with this function, when you draw the vertical line, you have 1x, correct? But you have 2y. So that means for the y, how many the x used how many times? More than once, right?
Yeah.
So it is a function or not?
No.
It's not a function. Okay, let me show you this. So if you have something like this, if you draw the vertical line right here, so how many times this line intersect with this function? People look at the green function. How many times the function intersects?
One.
Three times.
One.
3 times. No, it's 3 times. It's definitely 3
One.
The function is the u.
I got
The function is u. How many times the function intersect with the blue line?
One.
2.
1 right here.
Huh? Bro, I literally see.
What do y'all think? Three times.
Oh, I see 2 of them.
Yes.
So for that box equation, right, that you drew up the graph.
Uh-huh.
So x. So you're talking about x going into y, right?
Yes.
So, so it's not a function because it goes
That's what I'm
into 2.
saying.
Okay, that's simple.
So you see that the green function only interact with the line once. So that is a function, okay? But the one in the box, the sideways u, is not a function because how many times it interact with the line?
No.
Twice. So if it interact more than once, it's not a function. So this line we draw to determine if it's a function or not, we call it vertical line test. Yes.
So for the green one, right?
Okay, let's take a look at D. dy squared minus 2x equals 5. So we're looking for y, right? So how we do? We plus 2x. So basically you want to isolate the y. You plus 2x on both sides. So y squared equals 5 plus 2x. Then you want to get rid of square by doing the square root. So square root. I'm solving for y. So if you have a function, like an equation, and you want to see if it's a function, you have to solve for y. Okay? So I'm solving for y, but whenever you square root something, you're always gonna get n plus and minus. You're gonna get two answer, 5 plus 2x. Okay, let's take a look at this answer. Y equal plus, y equal plus and minus root 2 plus, 5 plus 2x. So, based on that, let me ask you, for each y, how many x can you have? That's right. Because y equal plus and minus, right? So,
Wait, why'd you get rid of the 2 from the y?
Because you want to find out the y by yourself. So any number that's not part of y, you want to get rid of on that side. So square root, so exponent 2, square is the one we want to get rid of. How you get rid of square? You square root both sides.
This is why you have the thing right here.
That's right.
That's like the simplification.
That's right. So you square root both sides, but do you get, you have the answer over there, right? So every single y, you have how many x right there? Plus or minus, how many x?
2.
That means 2x going to the same y, so it's not a function, okay?
So look, you know how you start the problem off, right? Just the base problem with the y to the second power.
That's a good question. How a function look like? You will see something like y equal x squared plus 3. So x could be 2 x's, right?
Yeah.
But it's just single y. What?
Why is it not a function?
Okay, let me record this. So you see here, I'm going to use red pen. X is x by itself, so there's only one x. But y is equal to plus and minus. That means how many y you have? 2 y's.
Wait, why would it be equal to plus and minus?
Because every time you square root something, your answer should be plus or minus. So just like you square root of 4, square root of 4 is plus or minus 2. Okay? So if you square root of y square, your y is actually can be plus and minus. So that means you have 2 y's corresponding to 1x.
But that's a function.
That is not a function.
But it's
Because
only
x
1x.
goes into both times.
What?
Remember me? Because
What?
right? It goes into y twice. So it can't.
So you cannot have 2 y's going to the same x.
It gotta be just one x going.
You could have 2x.
Yes, you have. So basically, you can only have one y.
Oh, okay.
Right. So you see the blue one, y by itself, right?
Yes.
But x squared, that means you have 2x, and then you have 1y, right? But you can have the 2x going to the 1y, it's a function, but not vice versa. You cannot have 2y.
So the reason we have 2 y's is because of the second power.
That's right.
Okay, I see it now.
But I cannot just look at that and be like, it's not a function.
Yes, you can. I'm just showing you why.
Oh, you showed me why.
That's right. You can look at that and say, however, you can look at that y squared. You say, okay, we'll have 2 y's.
It's wrong.
Not function.
Most of the time, yes, not function.
Wait,
Okay.
so I could just look at the base problem and be like, it's not a function.
It's not a function. Very good.
Because there's only one. Okay.
That's right. That's right. Okay, let me show you this. Page 7. Okay. So function notation, like when we have equation like y equal negative 6x. Okay. However, function notation, we do not write function as y. We write function as fx. Okay? So if we see something like fx equal negative 6x, it's the same thing. These two are equivalent. Okay? These two are equivalent. But one is linear equation, one is related function, but they pretty much mean the same thing. Okay? So, by knowing that, let's take a look at example 4. Example 4, we have a function gx equal x squared plus ax minus 24. So the question is, what is G6? What does that mean?
So do I just plug it in?
That's right. So basically, I know. So basically, function here, so y equal x squared plus ax minus 24. But
It's
what?
telling you to find it.
To tell you G6, that means if the x is 6, what is the GX, right? What is the G6? All you have to do is plug it in. So you just replace x with 6. Look at the TV. So replace the x with 6 with parentheses. Every time you replace something, you use parentheses. You get 36 plus 48 minus 24, and you got 60.
That's easy.
Right?
It get harder.
And then you solve.
Miss
You
Chang,
saw?
undersized one
Saw
word.